Welcome you all to the course System Analysis and Design. I am Ishara Devendra, lecturer at the University of Moratuwa. In today's lesson, we are going to learn about the process modeling concepts. Before moving forward, let's take a moment to get familiar with the standard color coding scheme we have been using throughout this course. We'll first look at the learning outcomes of this lesson. After completing this lesson, you will be able to describe process modeling concepts, explain process modeling tools, and develop process models for a given scenario. Let's see what is defined by the process modeling. A process model is a graphical way of describing how a business system should operate. It demonstrates the process and how data move among them. A process model can be used to document the current system or the new system being developed, whether computerized or not. Process models have been a part of structured system analysis and design techniques for many years. In system analysis and design, there is another requirement to create a process description. So let's see what is a process description. A process description documents the functional details of the system and describes a particular set of processing steps and business logic. The goal of the process description is to describe what the process does and produce extra information that the data flow diagram does not provide. The text-based process description provides more information about the process than the data flow diagram alone. If you want to know more details about the data flow diagrams, you can refer the previous lesson. So if the logic underlying the process is quite complex, more detailed process description is required to explain the logic inside the process. Along the software development lifecycle, we slowly move from the usual text descriptions of requirements into more specific descriptions that can be converted into very precise programming languages. In some cases, a process can be straightforward enough. When system analysts needs to have an effective communication with people, they require to use different techniques for a better understanding. So, structured English, decision table, and decision trees are some of these techniques that could be used for effective communication. And also, these are known as standard process description tools. According to the complexity of the problem domain, we can select any suitable technique. So let's discuss them one by one. Before moving to the process description tools, there are some terms that you should be familiar. The first one is modular design. When analyzing a functional primitive, the processing steps are broken down into smaller units in a process, which is known as a modular design. The foundation of modular design is a mixture of three logical structures which serve as building blocks for the process. Sometimes they are called as control structures as well. Each of these logical structures should have a single entry and exit point. So you may think that what are those logical structures? Here are the three logical structures which is defined as sequence, selection, and iteration. This figure represents the three basic structures in a graphical format. First one is sequence, second one is the selection, and the last one is looping. Let's discuss them. In sequence logical structure, the modules will be executed in the sequence in which they are written. In other words, the modules will be executed one after the other. Below is an example set of instructions to add two numbers and display the answer. So in this example, you can see the code as begin at two numbers and then get the first number and then get the second number, and then we can write the formula to get the total. The total equal first number plus second number. And then display the sum of your two numbers is, and then we can use the variable total, and then n at two numbers. This is how we can represent the sequence logical structure. Next one is selection. The selection structure will determine which particular step or set of steps to be executed. Also, the selection refers to as a decision. A selection statement can be used to pick a definite path depending on a condition. Below are two examples on how the selection could be used. So in the first example, you can see, if raining, then take umbrella, and then end if. Or we can say it as, if raining, then take umbrella, else put on sun cream, and then end if. Similarly, we can represent selection logical structures by using these condition statements. Last logical structure is the iteration. In iteration control structure, the completion of a process step is repeated until a specific condition changes. This is an example. While condition is true, then processes, and then end while. So we can use while loop to represent this control or logical structure. So you can refer more examples under this sequence, iteration, and the selection logical structures. So far, we have discussed about the process model, process description, and logical structures. The main objective of this lesson is to learn about the process description tools that I have mentioned in earlier slides. When the processing logic includes formulas or iteration, or when structured decisions are not complicated, we can use structured English. Structured English is use of the English language with the syntax of structured programming to communicate the design of a computer program to non-technical users. It is broken down into logical steps using straightforward English words. Simply we can say structured English is a technique for analyzing the decision process. When using the structured English, there are some practices you must adhere. First one is to express all logic concerning one of these four types. They are sequential structure, decision structures, case structures, and iterations. So I'll explain them in next slide. Next practice is to use indentation for readability. Final one is to use a restricted vocabulary, including standard terms used in the data dictionary and specific words that describe the processing rules. So these are the practices that you should follow when designing the structured English. In this figure, you can see the types of structured English and the examples. In sequential structure, we can use number of actions according to a sequence or some order. In decision structure, we can use if-then logical statements to represent the conditions. In case structure, we can use if-else statements together with case statement. To represent iterations, we can use do-while statements. So I'll explain them with examples, so you may get better understanding on this. The first example includes with if-then conditional statements. Here you can see it begins with if, and then if customer age is equal to 65, there the code mentions the condition. If the customer age is greater than 65, then billing rate is equal to senior citizen rate. Else, billing rate is equal to standard rate. This is how we can use the conditional statements. The next example includes the case statements. This example includes with do-while conditional statement. So you can see the example here. I think now you have the knowledge on how to represent structured English statements. And you can refer more examples and try to write structured English statements and practice. Then you can get more knowledge on the structured English. Next process description tool is decision tables. A decision table is a concise visual representation that shows every combination of conditions and their outcomes. System analysts usually use decision tables to specify a process and guarantee that they have considered all possible states. In decision tables, we mainly use conditions and actions. A decision table is a collection of columns where every column represents conditions and actions. Each column represents a particular business rule. A condition can be considered as a predicate test that must evaluate to true in order to execute the corresponding actions. In each rules column, you define the specific conditions and actions that comprise that rule. Now let's discuss about the components of a decision table. First one is the condition stub. It is in the upper left quadrant which lists of all the conditions to be checked. The next one is the action stub. It is in the lower left quadrant which outlines all the actions to be carried out to meet such condition. Next one is the condition entry. It is in upper right quadrant which provides answer to questions asked in condition stub quadrant. Final one is the action entry. It is in the lower right quadrant which indicates the appropriate action resulting from the answers to the conditions in the condition entry quadrant. So these are the components of a decision table. This is an example decision table for verify order process that consists of two conditions. In this example, the process description comprises two conditions such as product stock status and customer credit status. If both conditions are true, the order is accepted. Otherwise, order is rejected. Now suppose the company decides that the credit manager can waive the customer credit requirement. As a result, the number of conditions in the decision table will be increased to 3. Previously, there were only 2 conditions, as credit status is okay, product is in stock, and now the new condition statement is added as the waiver from credit manager. Therefore, the new table should be look like the following. Similarly, after creating the decision tables, we can simplify them by considering conditions and actions. Consider the following decision table regarding the employee salary maintenance, which consists of 2 conditions and 4 actions. Based on that, 6 rules have been identified in this decision table. By carefully analyzing the decision table, it can be noted that Rule 1, Rule 3, and Rule 5 can be combined together. In other words, we can say, for all the cases where the employee type of a particular employee is S, then irrespective of the hours worked, the action to be performed by the system should be pay-based salary. Therefore, the above decision table can be further simplified by combining Rule 1, Rule 3, and Rule 5. This is how we can simplify the decision table. So the simplified decision table is also shown here. Similarly, now we'll try to simplify the verify order decision table that we have already discussed in the previous slides. So there are 2 combination rules that we can consider here. The first one is, since the product is not in stock, the other conditions do not matter. And the second combination rule is, since the other conditions are met, the waiver does not matter. So we'll see the result in the next slide. After considering the combination rules, we can get the simplified decision table like this. From here, you can see the simplified decision table. Similarly, you can simplify the decision tables by using combination rules. Our next process description tool is decision tree. A decision tree is a powerful method for classification and prediction and for facilitating decision making in sequential decision problems. Simply, we can say a decision tree is a map of the possible outcomes of a series of related choices. Our next process description tool is decision tree. A decision tree is a powerful method for classification and prediction and also for facilitating decision making in sequential decision problems. Simply, we can say a decision tree is a map of the possible outcomes of a series of related choices. In a decision tree, the algorithm starts with a root node of a tree, then compares the value of different attributes and follows the next branch until it reaches the end leaf node. This allows an individual or organization to weight possible actions against one another based on their cost, probabilities, and benefits. As the components of a decision tree, we can discuss about decision node, chance node, and the end node. Decision node represents a decision and it is typically shown with the square. Chance node represents probability or uncertainty. It is typically denoted by a circle. An end node represents an outcome. It is typically shown with the triangle. This is how we can create a decision tree. It typically starts with a single node which branches into possible outcomes. Each of those outcomes leads to additional nodes which branches off into other possibilities. This gives it a tree-like shape. When drawing a decision tree, we can follow these steps. First, we can start with the main decision and then add chance and decision nodes and then continue to expand until every line reaches an endpoint. So by using these steps, you can design the decision trees. As a summary from today's lesson, we have discussed various tools and techniques that is used for system development during structures analysis. So we have already discussed about the process description tools as structured English, decision tables, and decision trees. Also, we have discussed how to simplify the decision tables. With that, we have come to the end of today's lesson. See you in the next lesson. Thank you.